Namaste all of you. My name is Dr. Ritu Singh Rajput, Faculty of Agriculture and Veterinary Science, Department of Food and Biotechnology. Today in our session, we have talked about the filtration, microfiltration and the membrane filtration. A membrane is a thin layer of a semi-permeable material that separates substances whereas a driving force is applied across the membrane and the process. Increasingly, there is some kind of used to removal of the bacteria, microorganism, particulates, and the natural organic materials, which can be impart color, taste, odor. Water reacts with the disinfectants from disinfection and the byproducts. As advancement are made of the membrane production and the module design, capital operating cost you continue to declines, the membrane possesses discussed. Here is the microfiltration, ultrafiltrations. So what is a microfiltration? Microfiltration is loosely defined as a membrane separation process using membrane within the pore size extremely 0.03 to 10 microns as a molecular weight cutoff of greater than 10 lakh Daltons and the relatively low feed water operating pressures and the extremely 100 to 400 kPa material removed by the microfilters, including sand, slits, clays, Gardia lambia, algae, some bacterial species. Microfiltration is not an absolute barrier for the virus. However, when used in the combination for the disinfection, microfilters appear to control these microorganisms in a water. There is a growing emphasis or the limiting concentration and the number of chemicals that are applied during water treatment by physically removing pathogens. Microfiltration can be significantly reduce chemical additions such as a chlorinization. Another application of the technology is from removal of a natural synthetic organic matter to the reduce fouling potential in normal operation. Microfiltration remove little or no organic matter. However, when the pre-treatment is applied, increased removal of organic material can occur. Microfiltration can be used as a pre-treatment to RO and the NF to reduce fouling potential. Both RO and NF have been traditionally employed for the desalt and removing. Now we have talked about ultrafiltration. Ultrafiltration is a pore size extremely 0.002 to 1.1 microns and the approximately 10,000 to 1 lakh Daltons and operating pressure of approximately 200 to 700 kPa. And ultrafiltration will remove all microbiological species removed by the microfiltration. It is a partial removal of bacteria as well as some viruses, but not all absolute barrier for the viruses. And the humic materials disinfection can provide such as a second barrier of the contamination and therefore recommended. The primary advantage of low pressure ultrafiltration membrane processes compared with the conventional clarification. There is no need for chemicals, and self-exclusion filtration is opposed to the media-dependent filtrations. Constant quality of the treatment waters in terms of the particles, microbial removal, process of the plant compactment, simple automations, and there's some kind of there is so this is the some kind of now we have talked about the ultrafiltration. Ultrafiltration is separate solution mixture of desirable and undesirable components, has smaller holes than the microfiltration membrane. It is driven forces pressure differential 2 to 10 bars to 25 to 30 bars, and in wide range of applications. It has like oil emulsion, waste treatment, treatment of van in dairy industries, and treatment of burn in dairy industries and concentration of biological macromolecules, electrocoated paint recovery, concentration of textile seizing. And now I will tell you what is the nanofiltration. Less pore size than the ultrafiltration membrane. The mass transfer mechanism is diffusion and the separates small molecules from the solution. Salicylic acetate and the aromatic polyamide type membranes, and it can be typically operated in the high recoveries. And it is the applications are in food, dairy, beverage, and the partial distillation when UF ultrafiltration precipitate of the retain as required, the and the purification of spent cleaning places. So there are some kinds of a filtration. There's some advantage of the membrane processes. They are usually continuous and comparatively loss energy utilization. No phase change of the contaminant requires. Small temperature are changes. Modular design are important. Minimum of moving part is also important, and physical separation of the contaminants. So these are all about the different kinds of filtration, which is important. In microfiltration is the rapidly food collides and low pressure is 2 to 4 bars. Recovery happened up to 100% pH up to 1 to 13, and high temperature possible, high residence of the oxidization agent. It has a stream sterilization possible and hygienic design available. So this is all about the filtration, microfiltration, ultrafiltration. So if we have talk about the exam point of view, you have to know about the difference between ultrafiltration and the microfiltration, and what is the and you have to know about nanofiltration. Thank you so much.